Hello everyone. I am Anuradha Sharma, your maths teacher. Today I would discuss part 2 of inverse trigonometric function. In case you have not seen part 1 of inverse trigonometric function, I would recommend you to do that first. I am leaving the link in the description box below. Now, let's get it straight to what we have for today's agenda. First, we would be discussing questions on principal value branch of inverse trigonometric functions. Second, two properties of inverse trigonometric function. So what we are waiting for, let's get started. You have studied domain and range in part 1 video. Find the principal value of the sine inverse 1 upon root 2. So let us consider sine inverse 1 upon root 2 is as a theta. Shift the sine inverse in right hand side. So we get sine theta is equal to 1 upon root 2. So what the value of 1 upon root 2 shows by the sine theta. So we can easily locate sine theta is equal to the sine pi by 4 because sine pi by 4 shows 1 upon root 2 is the value and theta is belongs to the minus pi by 2 to pi by 2. So that's why we can write the theta is pi by 4 because it is lies in between minus pi by 4 and pi by 4. Now find the principal value of sine inverse minus root 3 upon 2. So let us consider sine inverse minus root 3 by 2 as a theta. Then sine theta is equal to the minus root 3 by 2. Root 3 by 2 value in terms of the sine, it is sine pi by 3. So that's why we can write sine theta is equal to minus sine pi by 3. And again, theta should be lies in closed interval minus pi by 2, pi by 2. So that's why we can say theta is equal to minus pi by 3, where theta is belongs to the closed interval minus pi by 2 and pi by 2. Now, find the principal value of cosec inverse minus 2 upon root 3. So again, we have to write cosec inverse minus 2 upon root 3 as a theta. So we can write cosec theta is equal to minus 2 upon root 3. 2 upon root 3 is the value of cosec pi by 3. So that's why we can say cosec theta is equal to minus cosec pi by 3 and theta belongs to close interval minus pi by 2 except the 0 degree value. So that's why we can say the value of the theta is equal to the minus pi by 3. That's why cosec inverse minus 2 upon root 3 is equal to minus pi by 3. This is the principal value of cosec inverse minus 2 upon root 3 and minus pi by 3 belongs to the closed interval minus pi by 2 except the 0 degree. Fourth part, find the principal value of tan inverse minus 1. So again consider tan inverse minus 1 is as a theta. If tan inverse shift in right hand side, so it becomes trigonometric function tan theta. So we can write minus 1 is equal to tan theta. Now, tan theta is equal to the tan minus tan pi by 4 and theta value belongs to close interval minus pi by 2 and pi by 2. So we can write theta is equal to minus pi by 4 because this value is lies in between minus pi by 2 and pi by 2. So we can say principal values of tan inverse minus 1 is equal to the minus pi by 4. Find the value of tan inverse root 3 minus sec inverse minus 2. Here are two terms is given in the question. So first of all, we will solve tan inverse root 3. Let tan inverse root 3 as a theta. So we can say tan theta is equal to root 3 and then tan theta is equal to tan pi by 3. So that's why we can say theta is equal to pi by 3 because it is belongs to the closed interval minus pi by 2 and pi by 2. Now we need to find the value of sec inverse minus 2. So that's why consider it is as a alpha. Now we can write sec inverse minus 2 is as a alpha. So minus 2 is equal to sec alpha. So look at the value of 2 in the sec terms. So we get sec pi by 3. So we can write sec alpha is equal to the minus sec pi by 3 where alpha is belongs to the closed interval 0 to pi except the pi by 2. So we can write the alpha is sec alpha is equal to sec pi minus pi by 3 and then we get sec 2 pi by 3. So that's why alpha is equal to 2 pi by 3 because this value is lying in between 0 and pi except the pi by 2. Now we have to put this value in the given expression tan inverse root 3 minus sec inverse minus 2. So we get pi by 3 minus 2 pi by 3. Simplify this value. After simplifying, we get this is equal to minus pi by 3. So this is the value of tan inverse root 3 minus sec inverse root sec inverse minus 2. This is the assignment for you based on principal value branch of inverse trigonometric function. You pause your video and note down these questions for solving it. Now, we will study about the properties of inverse trigonometric function. Sine. Sine inverse theta is equal to the theta for all the value theta is belongs to closed interval minus pi by 2, pi by 2, and cos inverse cos theta is also equal to the theta for all theta belongs to the closed interval 0 to pi. Similarly, tan inverse tan theta is equal to the theta for all theta belongs to the minus pi by 2 to pi by 2. Cot inverse cot theta is also equal to the theta for all theta is belongs to the 0 pi. And similarly, we can easily write about the sec inverse sec theta and cosec inverse cosec theta. These also equal to the theta. But the condition for the sec inverse sec theta is theta belongs to close interval 0 pi except the pi by 2, and cosec inverse cosec theta is equal to the theta for all the theta belongs to the closed interval minus pi by 2 except the 0. Similarly, we can write sine inverse x. So this is equal to the x. For all x is belongs to the minus 1 and 1. Sine cos inverse x is also equal to the x for all x is belongs to the minus 1 and 1. Similarly, we can easily write tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. These all are equal to the x, but the conditions is changed for each inverse trigonometric function. If you remember trigonometric function, these are the same interval in which our trigonometric function restrict to make them bisecting. So that's why their inverse exists. So that is very important to learn the condition. So that's why we can easily understand sine inverse sine theta is equal to the theta when theta is belongs to the minus pi by 2 to pi by 2. Similarly, sine inverse x, it is equal to the x, and x is belongs to the closed interval minus 1, 1. X shows the domain of inverse trigonometric function, and theta shows the range of inverse trigonometric function. So that's why whenever the result is theta, so we have to write the condition based on the range, and whenever we have to use the sine inverse axis as a x, it means we are getting the value of x, so that's why it should be lies in the domain. So these are the two conditions of these are two properties of inverse trigonometric function. So we have to learn these two properties. Now, we will solve the question based on these two properties. So look at question number 1. Evaluate. First part, sine inverse sine pi by 3. Sine pi by 3, it is mentioned in the bracket. So that's why we can write this is equal to the pi by 3 by applying this property. Sine inverse sine theta is equal to the theta where theta is belongs to the minus pi by 2 pi by 2. So that's why we can easily locate pi by 3 is belongs to close interval minus pi by 2 pi by 2. In second part, cos inverse cos 9 pi by 8. So this, if we write 9 pi by 8, so we know very well 9 pi by 8 does not lie between 0 and pi, because we have studied this property. Cos inverse cos theta is equal to the theta for all theta belongs to the close interval 0 pi. So that's why it cannot be equal to the 9 pi by 8 because it does not lie between 0 and pi. So we have to make some changes in 9 pi by 8. If we make the changes, so we can write cos 2 pi minus 7 pi by 8. So now we have to apply cos 2 pi by minus theta. So cos 2 pi minus theta is equal to the cos theta. So that's why we can write cos 7 pi by 8. Now we get cos inverse cos 7 pi by 8. This is the value of cos inverse cos 9 pi by 8. Afterwards, we can apply this property. Cos inverse cos theta is equal to theta. So that's why we can write this is equal to the 7 pi upon 8, and this value is belongs to the 0 and pi. So that's why this is the result of cos inverse cos 9 pi 8. So cos inverse cos 9 pi by 8 is equal to 7 pi by 8. Look at fourth part, tan inverse 23 upon 18. Now, inverse trigonometric function, it is given in a bracket. So, how to evaluate? So, again, tan inverse, this is equal to the x. So, that's why we can write this is equal to the 23 upon 18. And 23 upon 18, it is belongs to the r. R is represent real number. So we can write the value of tan inverse 23 upon 18 is equal to 23 upon 18. This is belongs to the R. Look at the next point. Next question. Fifth part. Sine inverse 2 upon 5. If you write the value of this, so apply the property. Sine inverse x is equal to the x for all x belongs to the close interval -1 and 1. So we can say this is equal to the 2 upon 5 because 2 upon 5 lies between -1 and 1. So that is the value of sine inverse 2 upon 5. So that's it for today. You revise more and more to learn self-adjustment properties and domain and range of inverse trigonometric function. Thank you.